Okay, ladies and gents, on this one, we're going to be looking at a linear inequality, and I'm ready to just dive right into it. Here we go. All right. Okay. Come on with me. Where am I? Where am I? All right. So, let's look at our piece of graph paper. We have, there we are, our homemade piece of graph paper, and we have the statement y is greater than 5x, which is an inequality. And what we want to do first is we want to solve this by first starting with the boundary line, which means we're going to pretend that this says y equals 5x. Now notice that there's really a plus 0 behind here, which tells me that 0 is the y-intercept of this boundary line. So I'm going to put a dot on 0, 0. I'm going to use the slope in front of the x, which is 5 over 1. So we're going to count from here up 5, 1, 2, 3, 4, 5, and over 1. I'm going to play a connect the dots game, and notice that because this says strictly greater than, I'm going to use a dotted boundary line rather than a solid. And what that means is I now have two regions that I have as possible candidates for holding the answers. I have the region above the line and I have the region below the line. And one of the best ways to decide which region to test is to use a test point. So we're going to come down here. The original inequality is y is greater than 5x. We're going to go back up here. Now normally the best test point to use is 0, 0, but I can't use that test point because the boundary line runs through it. So how about we do something like this? How about I come over here and I pick this point right here, which is the ordered pair what? 2, 0, and I will use that as my test point. TP for test point. If I come down here and I'm trying to test the ordered pair 2, 0 into my inequality, that means 0 goes in for y and 2 goes in for x. 0 is larger than 10, which is false. So what that means now, when I go back up to my picture, when I test 2, 0, it tells me no. It says it did not work. That means that all of the points around 2, 0 are also no's. So where would the yeses be? Well, they would be on the other side of the fence. The yeses are over here. You don't really have to go through the whole procedure of testing another point. If one side's no's, the other side are yeses. And our answer, the set of ordered pairs that work, are always the yeses shaded in. And what you also want to make sure when you're showing your answer to this problem is that your boundary line is dotted or broken. If this had said greater than or equal to, then the boundary line would have been solid, indicating that the points on the line were included in our solution. But in this case, they're not. Thank you.